What is up, guys? We are back. So if you guys follow me on Instagram, you know that I sold my diesel 2 or so weeks ago, and I just ended up buying a new to me 2017 Ford F-150 on Saturday. So I'm pretty stoked. You know, I've never been a Ford guy. I've always been Chevy, and there was a few things I was looking at as far as a new truck goes, and I was really looking to get something in the 2016 to 2018 range. I really wanted to get back to a gasser, just because of the cost, maintenance, everything on a diesel was ridiculous, and I just couldn't afford the fuel, the maintenance, everything all the time, you know. So I ended up selling the diesel and bought this 2017 F-150. So I'm pretty stoked. This truck seems like it's gonna be a great truck. It is a Ford, so I don't know. I got the 4-wheel drive 3.5 liter twin turbo engine, 10-speed tranny, the whole towing package. This is the XLT model. Super nice interior, beautiful truck though. I'm really happy with it so far. I bought it on Saturday. Today is Tuesday, and the truck got broken into this morning, or last night, in my driveway. I figured it out this morning when I went to leave for work, and opened the truck up, and the center console was wide open, the glove box was wide open, and one of the papers that was in the glove box was sitting on the passenger seat, and all the envelopes of papers I had in the center console were gone. All my dealer papers, warranty papers, all the papers for the truck, my loan papers, those were all stolen. I had some SCO stuff in the center console that was stolen. I happened to leave my wallet in my truck the day it got broken into, so I don't know, it is what it is. Just sucks. Luckily, I'm so glad they did not damage the truck, but the truck seems to be all right. So I'm pretty upset. You know, I've never bought anything new from a dealer, and this is the newest, nicest thing I've ever owned. So it's just unfortunate. I don't know why people do this. Whatever, dude. They didn't take the truck. I still got it. So it is what it is. But super stoked with this truck. Yeah. So back to real life things now. We've been staying real busy. I've been having some help here on the shop. It's been kind of weird. You know, there's a lot of the whole like coronavirus thing going around right now. I'm sure all of you guys know about that. I've been slamming away building the whole new suspension for the rear end of the race car. So my help has been limited. We're not allowed to have visitors. We're not allowed to have people here. Basically, I don't have any help. But it's okay, you know, it slows down the process a little bit, but well, gotta do what you gotta do. You know, nobody plans for this kind of stuff. So yeah, staying real busy. Working on the fixtures for the rear upper arms. Waiting on a couple uniball cups so I can build those. I got the trailing arms and new rear uprights sitting here on a pallet, ready to get built. So I gotta prep all the parts, clean everything up, acetone all the parts, deburr all the parts, you know, clean it all up before I can even weld them, because obviously I'm TIG welding everything. It's coming out nice though. I'm happy with it. So yeah, that's what's going on here. I'm gonna talk a little bit about, I'm gonna kind of walk through the procedure of building the other lower radius arm, just so you guys kind of have an idea of how I do it, the steps that I have to go through, and the process and time that it takes. So let's get into it. So I have all my pieces laid out. So these are the pieces I'm going to be using to build the arm. That will turn into this. So I'm going to kind of walk through step by step. I'm going to use two different machines. I'm going to use our Lincoln TIG and then our multi-process Miller machine. So I'll start with the Lincoln and I'll finish with the Miller, just to show you guys a couple different welders, a couple different techniques, a couple different styles. What I like about this one, the quality of weld, as well as water cooled. For my personal style, I love this welder. This thing's old, it's beat up, but she works like a champ. So that one we've had forever. We've had that one for like 10 years. That's the Square Wave 275, I think. And then this is the Miller 220. So this is AC, DC, and stick. So that one will do a lot of different things, and it's a lot smaller package. So for you kind of garage guys or small shop, these machines are a lot more expensive. Those machines are a little bit cheaper, but you can do a lot of different stuff with them. It's a MIG, TIG, stick, all in one. What I don't like about that one is it is air cooled, unlike the Lincoln that's water cooled. So a couple different things right off the bat, just so you guys know. So I'm gonna start with this one. You can see I already have this piece prepped. So when I say prepped, that means I deburr the edges. I use a Scotch-Brite wheel on a little angle grinder, an air Scotch-Brite wheel. So that would look something like this. To deburr the edges on the part, as well as clean all of the weld surfaces. So it's really important when you get steel. This is all chromoly. Most steel is going to have a film over it that TIG welding does not like. TIG is a very clean process, to whereas something like MIG is a very dirty process, and you could literally have an old crappy piece of metal and MIG will still weld the same. TIG, if you don't clean it super well, and if you have a dirty weld, it's going to sputter, you're going to have porosity, and it's not going to look pretty, and it's not going to hold. So it's really important to clean the metal very carefully. Make sure the edges are nice and smooth, no start stops from the laser, and clean all the edges that you're going to be welding on before you start welding, or else you could run into porosity. So I'm going to start with deburring the rest of the pieces just to show you guys. You can see I've already cleaned the cups and installed my brass plugs into the uniball cups that I'm going to be using. I just did that just so it was already done. I grease these before I put them in, because after you weld them, sometimes the cups change shape just a little bit, and these brass pucks are to help the warpage on the cup as you weld all over it. Never weld uniball cups without those in. You can make them, there's nothing special to them, or you can buy them from somewhere like Cartech or Mackenzie's. Now that's done, I'm gonna deburr the rest of these parts, clean them all up, and we'll start welding. Now is when I start laying all the pieces together. Luckily, these are pretty simple part to build. There's not much to them. There's 2 outer shells, inner bracing, and then uniball cups, a couple overlay plates, and they're done. Things like the upper arms or the lower arms, trailing arms, are a lot more complex than these. This is a 8 or 10 part, so this is a very easy part to build. So what I'm going to do first is I'm going to bring the shell. I'm going to set the shell in, make sure it fits good. Alrighty guys, so before I start welding, I'm going to talk a little bit about machine setup. Granted, I don't know everything. I'm a young adult. I don't know everything. I know a little bit, and I stick stuff together, so take it with a grain of salt, listen or not. You can call me out in the comments down below if whatever I'm saying is wrong. If you can teach me something, I'm more than willing to listen, but this is how I go about my system. This is DC. I usually have my balance set on balanced on this Lincoln machine. It's going to be different for aluminum, and that'd be AC. Tacking parts, I'm usually around 185 depending on the thickness of the stuff. So here I'm doing 3/16 to 1/8 inch chromoly. So 185 will be fine. I don't go too hot on tacks just in case I need to take something apart that I tack or whatever. So let's get started on tacking. Alrighty guys, so with TIG, it's very important that you have a clean tungsten. Obviously everyone has their own setup, whether they like a certain cup size, stick out, no stick out, whatever. I typically weld with like a finger's width sticking out of the cup. Remember, the parts are clean, they're prepped, they're ready to be tacked now. So I'm going to line up my key slots. just a light tack, just in case I need to pull it apart. Remember that. The goal in mind is just to seat the parts the way they want. Sometimes you can do it with a little bit of convincing with a hammer, sometimes not, so it's not that big of a deal. Again, you want to make sure all of your edges are lining up right, making sure all the parts look like they're bent and formed correctly. I'm going to bring my other shell over. You just got to kind of figure out what the parts want, you know. I have the shell all tacked together now. It's all one piece. I got my internal rib in there, my internal structure. So now what I'm going to do is... Okay, so now what I'm going to do is get my uniball cups in there. You also have to remember when you build things like this, one's the left, one's the right, you want to try to build your parts to never be riding on the snap ring that holds the uniballs in. You want to be putting the weight of the vehicle or the load directioning on the machined face of the uniball cup. Alrighty guys, so I just finished first pass on this corner. So basically what I did was just put enough heat into it. Basically now what I'm going to do is, now that I got a root pass on this corner and I filled as much on the inside as I could, I'm going to drop this shell over. I might have to open these notches up a little bit just in case these welds pop out a little bit, the root pass ones that I already started. Notch this back a little, drop this over, tack it, and weld it up. So let's get going on that. Get laser cut pieces, sometimes they can't break around where the uniball goes. So basically all you're gonna have to do is put a tack on both sides, and then you're just gonna hammer the flap down as much as you can until you can get to a spot where it's touching again. Lay 2 more tacks, hammer it down more, lay 2 more tacks, hammer it down more, and then obviously by the end it'll be fully wrapped around the uniball cup. And you can start welding. So here we are pretty much there. I've gotten this whole piece. It needed a little bit of work to get to fit around the arm. I had to open it, I had to spread it up, spread it open a little bit, and then I was able to get it on the arm all tacked up, and I'm almost ready to get going on this thing. So before I start welding this section, I'll stitch weld the whole arm itself together, just so these tacks I have holding the shells together currently don't break. I'll put a single pass, or I'll put a first pass on this uniball cup over here so that doesn't move, and then I can start burning this thing together. Alrighty guys, so we're moving over here to the Miller machine. We set it up for TIG. I'm going to set it at 200 and 0.7 on the pulsar. Depending on what I'm welding, I might change that because I want to move a little slower, a little faster. So I'm going to start at 0.7 and see where that gets me. So I'm going to start doing this long straight pass now that I have my root pass done on both sides, and let's go from there. So I just did my first portion of the pass. I'm going to show you guys the difference between the 2 welds. Always make sure you let your post flow do what it needs to do. You're not just wasting gas, you're just helping cool down the final part of the weld, so when you start your next weld, it's not dirty. So this is what I just did with the pulse setting. I did this one on the Lincoln. So you can see they look similar. This one's just really good about controlling heat and the on-off. When you're manually pulsing, it's harder to nail the same on the pedal, off the pedal amperage every time. Alrighty guys, so today we're working on some tie rods. So these are gonna be the new rear tie rods, and I wanted to get all the main work done and then talk about what I did and show you guys what's going on here. So basically what we got, I have my end-to-end dimension. You can see it's super accurate, scribbled in here on the bench. So that's end of bung to end of bung, right? I set my pieces in place, measured out my tubes, came up with what I needed to come up with, and then started cutting parts. So basically what I'm gonna do to keep the tie rod straight is I'm gonna slide this little guy up in there if it wants to cooperate. Yep, I'm gonna do that. I'm gonna do a little bit of that. I'm gonna leave a gap. I am going to fully weld this, and the whole reason behind having this little inner tube is so I can put a lot of heat into it without blowing through the tube. I'm gonna slide this guy up to here. It's basically just an overlay cap for the whole thing to keep this nice and strong, this whole area right here. So this is gonna be at the wheel side, this is at chassis side. And then come over here, slide in my other bung, so nice and smooth there. Again, weld all the way around, plug weld. So this thing's gonna be super beefy. This is 1.5" 120, 1 3/4 120, and then 1 1/4 120. Again, this isn't a super critical, it is a critical piece, but the way that this part sees loads is not, it's really just push-pull. The process is very similar to when I was building the lower lateral links. And now I'm going to start tacking this thing together, make sure my end-to-end measurement is still good, and then I can fully burn this thing in. So I'm going to get welding. I want to talk to you guys a little bit about that. I hope you learned something, and let's get rolling.